And coterminal angles is when the position of more than one angle lands on the same terminal arm. Okay? All right, example 2. Finding coterminal angles using unusual domains. So sometimes you just have to watch out for what is given. This right here is called the domain. Okay, that's called the domain. So whatever's given to you, you have to follow the domain or give a general solution. Okay, so in this case, it's asking us to find all coterminal that are between negative 720 and 360. Okay, the first thing we want to do is let's draw the negative 70 into our quadrant. So negative 70 is roughly about there. Okay, so I draw the angle in. Now we have to list all the coterminal angles. So the coterminal angles are going to be, okay, so let's do the positive one first. Let's go 360. And let's add it to what was given, so negative 70. All right, and what I get is, what is that? 290. Okay, so that's coterminal. Now just check to see if it fits within my domain. It does, so happy, check mark, good. Now watch what happens if I did 2 revolutions, which we know is 720, right? Now if I subtract it from that angle that they gave us, so negative 70, right? I get 650, correct? Now this is a problem because if we look at our domain, 650 is beyond the 360 domain that they gave me. So this is not going to be an answer. So that means I have to go to the negative side now. So let's go negative 360. And we subtract the 70 that was given. And we get negative 430. All right, and that's in the domain, so you're happy. Now let's try 2 revolutions, okay, which is going to be negative 720, take away 70, and what I get is negative 790. And if you look up at your domain, no good. Okay? So my answers are just these 2. Okay, the next topic, topic 2, the unit circle. Very important. Okay, the unit circle comes from, if you go over here, 1, and put a dot, which means that coordinate is 1, 0. This coordinate up here would be 0, 1. This would be negative 1, 0. And this point down here would be 0, negative 1. Okay? Which means this radius right here, that radius of that circle, which is 1. So this line right here, this blue line hitting that dot, is 1. Because if this is a radius, and that's a radius, and that is 1 unit, you know the radius is 1. So the key thing is when you see the word unit circle, just remember that the radius, okay, the radius equals 1, which helps you with the hypotenuse, okay, the longest side of the triangle, because we're going to create a triangle here. The hypotenuse side is also equal to 1. Okay, so just remember that. It's very important. Okay, now why did I mention hypotenuse? Because it asks us to find the values of sin, cos, and tan. So when I see those words, it means those right triangles that we did in grade 10. So let's make this into a nice right triangle. Okay, there's my right triangle. Now, we need some sides labeled because we're going to be doing our opposite, adjacent, and hypotenuse stuff, because that's our trig stuff. Remember the back in grade 10, hopefully, saw, ka, toa. Okay, so you got to remember that. Okay, so what's this measurement from here to there? Well, that's your x-axis, right? And this is your x value, and they just use m. So it's m. We don't know what it is. They're just using m. This is your y going up and down. That's your y coordinate. So that's your n. All right, so once you have your triangle nicely labeled, we can answer these questions. So sine of theta, and theta is always at origin down here, okay, is the opposite, which is n, over the hypotenuse, which is 1. So we can just say n. Okay? Cosine Alright, so the cosine of theta, which is the adjacent, which is down here, adjacent, which is m, over the hypotenuse, which is 1. And we can just simplify that just to m. And the last one is tangent. Okay. The tangent is the opposite n, over the adjacent, which is m. Okay? So that's the unit circle. Okay, now, when we have to determine coordinate points of a unit circle, we have to remember that unit circle means the radius, or the hypotenuse, or sometimes you can say the c squared in this case, the c side, has to equal 1. Okay? So how do I know if these points are on the circle? Well, it's just Pythagoras. Remember, your a squared plus b squared equals c squared. So I'm going 4 squared, or 4/5 squared, I should say. And I add it to negative 3/5. I square that. And it has to equal 1. If it doesn't equal 1, it's not on the unit circle. So let's just do some basic math. So 4 squared is 16. And 5 squared is 25. And we add it to negative 3 squared, which is 9. And 5 squared is 25. And then we add the numerators, because our denominators are already at 25, so we don't have to create one. And we get 25 over 25, which equals 1. So happy, yes. Okay, let's check this other one. So we got root 5 over 8. And we square that. And we add it to 7 over 8. And when we square a square root already, see that's square. So what you're doing right here is you're going root 5 times root 5, which equals the square root of 25, which equals 5. Okay? And then 8 squared is 64. Okay? And then 7 squared is 49. 8 squared is 64. And we add the numerators now, we get 54 over 64. And we say no. It's not on the unit circle because this does not equal 1. Okay? Okay, so you can try this one on your own and see how you do. So you can pause and then check your answer. Okay, and I got 16 over 16, which equals 1, and you say yes. All right, now example 3 is we have to determine the missing coordinate for points on the unit circle. So there's that key word, or words, unit circle. Okay, the first thing was let's draw a diagram, because diagrams help us a lot. It's visual. Okay, so now we know that we're in quadrant 2. So we're in this quadrant right here somewhere, right? So now the x, this guy right here, we don't know. So let's call that x. The y value, the second one in the coordinate, is 2/3. So I know the length of that is 2/3. All right? And because it says unit circle, and I told you that earlier, that's the 1 right there. Okay? So we do Pythagoras theorem. So 1 squared, because we have the hypotenuse or the c, subtract 2/3, and that's squared. That equals the x squared. Okay, we know 1 squared is 1, minus 2 over 3 squared is 4 over 9, because 2 times 2 is 4, and 3 times 3 is 9. Okay. And then we got to make this into a common denominator with 9. See, this is 1, and this has got a 9. So 9 over 9 is the same thing as 1. But now it has the common denominator, which I'm looking for. And now I subtract the numerators. 5 over 9 equals the x squared. And then my last step is we got to get to x, not to x squared. So now we square root that, square root individually now. Don't square root a whole big thing. It's a fraction. So the square root of 5 is, I don't know.